Next, let's look at the second submodule, which is Agile development techniques. The ideas underlying Agile methods were developed around the same time by a number of different people. However, the most significant approach to changing software development culture was the development of extreme programming, which we will emphasize in this module. Extreme programming approach was developed by pushing recognized good practice such as iterative development to extreme levels. For example, in extreme programming, several new versions of a system may be developed by different programmers, integrated and tested in a day. Figure shows the extreme programming process to produce an increment of the system that is being developed. In extreme programming, requirements are expressed as scenario or user stories, which are implemented directly as a series of tasks. Programmers work in pairs and develop tests for each task before writing the code. All tests must be successfully executed when new code is integrated into the system. Thus, there is a short time gap between releases of the system. Extreme programming was controversial as it introduced a number of agile practices that were quite different from the development practice of that time. These practices reflect the principle of the Agile Manifesto, including: first, incremental development is supported through small, frequent releases of the system. Requirements are based on simple customer stories or scenarios that are used as a basis for deciding what functionality should be included in a system increment. Second, customer involvement is supported through the continuous engagement of the customer in the development team. The customer representative takes part in the development and is responsible for defining acceptance tests for the system. Third, people, not process, are supported through pair programming, collective ownership of the system code, and a sustainable development process that does not involve too long working hours. Fourth, change is embraced through regular system releases to customers, test first development, refactoring to avoid code degeneration, and continuous integration of new functionality. Lastly, maintaining simplicity is supported by continuous refactoring that improve code quality and by using simple design that do not unnecessarily anticipate future change to the system. In practice, the application of extreme programming as originally proposed has proved to be more difficult than anticipated. It cannot be readily integrated with the management practices and culture of most businesses. Therefore, companies adopting agile methods pick and choose those extreme programming practices that are most appropriate for their way of working, including user stories for specification, refactoring, test-first development, and pair programming. Software requirements always change. To handle these changes, Agile methods does not have a separate requirements engineering activity. Rather, they integrate requirements elicitation with development. To make this easier, the idea of user stories was developed, where a user story is a scenario of use that might be experienced by a system user. As far as possible, the system customer works closely with the development team and discuss these scenarios with other team members. Together, they develop a story card that briefly describes a story that encapsulates the customer needs. The development team then aims to implement that scenario in a future release of the software. An example of a story card for the man care system is shown in the figure. This is a short description of a scenario for prescribing medication for a patient. User stories may be used in planning system iterations. Once the story card have been developed, the development team breaks this down into tasks as shown in the figure and estimate the effort and resources required for implementing each task. This usually involves discussion with the customer to define the requirement. The customer then prioritizes the stories for implementation, choosing those stories that can be used immediately to deliver useful business support. The intention is to identify useful functionality that can be implemented in about 2 weeks when the next release of the system is made available to the customer. The format of the user story as shown in the slide. The template should include the title and concise description. Of course, as requirements change, the unimplemented stories change or may be discarded also. If changes are required for system that has already been delivered, new story cards are developed and again, the customer decide whether these changes should have priority over new functionality. Therefore, agile requirement traceability is a must in order to produce quality software effectively and efficiently. The idea of user stories is a powerful one where people find it much easier to relate to these stories than to use a conventional requirement document or use cases. User stories can be helpful in getting user involved in suggesting requirement during an initial pre-development requirement elicitation activity. However, the principal problem with user stories is completeness. It is difficult to judge if enough user stories have been developed to cover all of the essential requirements of a system. It is also difficult to judge if a single story gives a true picture of an activity. This is because experienced users are often so familiar with their work that they leave things out when describing it. Fundamental principle of traditional software engineering is that we should design for change. We should expect future changes to the software and design it so that these changes can be easily implemented. However, extreme programming has discarded this principle on the basis that designing for change is often wasted effort. It is not worth taking time to add generality to a program to cope with change. In practice, changes will always have to be made to the code being developed. To make these changes easier, the developer of extreme programming suggested that the code being developed should be constantly refactored. Refactoring means that the programming team look for possible improvements to the software and implements them immediately. When team members see code that can be improved, they make this improvement even in situations where there is no immediate need for them. A fundamental problem of incremental development is that local changes tend to degrade the software structure. Consequently, further changes to the software become harder and harder to implement. Essentially, the development proceeds by finding workarounds to problems, with the result that the code is often duplicated, parts of the software are used in inappropriate ways, and the overall structure degrades as code is added to the system. Refactoring improves the software structure and readability, and so avoid the structural decline that naturally occurs when software is changed. Examples of refactoring include: first, the reorganization of a class hierarchy to remove duplicate code. Second, the tidying up and renaming of attributes and methods. And lastly, the replacement of similar code section with calls to method defined in a program library. Program development environment usually include tools for refactoring. These simplify the process of finding dependencies between code sections and making global code modifications. In principle, when refactoring is part of the development process, the software should always be easy to understand and change as new requirements are proposed. However, in practice, this is not always the case. Sometimes, development pressure means that refactoring is delayed because the time is devoted to the implementation of new functionality. Some new features and change cannot readily be accommodated by code-level refactoring and require that the architecture of the system to be modified. One of the important differences between incremental development and plan-driven development is in the way that the system is tested. With incremental development, there is no system specification that can be used by an external testing team to develop system tests. As a consequence, some approaches to incremental development have a very informal testing process in comparison with plan-driven testing. Extreme programming developed a new approach to program testing to address the difficulties of testing without a specification. Testing is automated and is central to the development process, and development cannot proceed until all tests have been successfully executed. The key features of testing in extreme programming are: first, test-first development; second, incremental test development from scenarios; third, user involvement in the test development and validation; and lastly, the use of automated testing frameworks. Another innovative practice that was introduced in extreme programming is that programmers work in pairs to develop the software. The programming pair sits at the same computer to develop the software. However, the same pair do not always program together. Rather, pairs are created dynamically so that all team members work with each other during the development process. Pair programming has a number of advantages. First, it supports the idea of collective ownership and responsibility for the system. Second, it acts as an informal review process because each line of code is looked at by at least two people. Third, it encourages refactoring to improve the software structure. You might think that pair programming would be less efficient than individual programming. In a given time, a pair of developers would produce half as much code as two individuals working alone. Many companies that have adopted Agile method are suspicious of pair programming and do not use it. Other companies mix pair and individual programming with an experienced programmer working with a less experienced colleague when they have problems. Formal studies of the value of pair programming have had mixed results. Using student volunteers, researchers found that productivity with pair programming seems to be comparable to that of two people working independently. The reasons suggested are that pairs discuss the software before development and so probably have fewer false starts and less rework. Furthermore, the number of errors avoided by the informal inspection is such that less time is spent repairing bugs discovered during the testing process. However, studies with more experienced programmers did not replicate this result. They found that there was a significant loss of productivity compared with two programmers working alone. There were some quality benefits, but this did not fully compensate for the pair programming overhead. Nevertheless, The sharing of knowledge that happens during pair programming is very important as it reduces the overall risk to a project when team members leave. In itself, this may make pair programming worthwhile.